Okay, rational functions. Capital R of x is equal to capital N of x over capital D of x. Capital R stands for rational, capital N is for numerator, capital D is for denominator. This is a polynomial function on the top. We have a polynomial function on the bottom. When you want to graph our rational function, you're going to have to factor both the numerator and the denominator. So I'm going to call that our factored form. So this definition is polynomial form. When we factor it, it'll become factored form. To find your vertical asymptotes, you have to factor the denominator and set all your factors equal to 0 and solve for x. Once you solve for x, these will be the equations of your vertical asymptotes. For your horizontal asymptote, we're going to compare the leading terms of n of x and d of x. So we're going to use this polynomial form right here. So case 1 says if n is less than m, that means the top power is less than the bottom power. So that means the top power, that's the degree of the numerator, is less than the degree of the denominator. In workman's terms, top power is less than bottom power. If that happens, your horizontal asymptote is y equals 0. Doesn't matter if you have a 1 over and a 2, 2 and a 3, 2 and a 4, 2 over 5. As long as the top power is smaller than the bottom power, it's y equals 0. Case number 2. Now the two powers, both top and bottom on your leading terms, are equal to each other. If that happens, then your horizontal asymptote is automatically a over b. That's the ratio of your leading coefficients. In case 3, now the top power is bigger than the bottom power. You do not have a horizontal asymptote if this occurs. You have an oblique asymptote. So you literally will have to take the denominator, divide it into the numerator, and we may have to do long division here. And when you divide it, whatever you get for a quotient up here, that's your slant asymptote. And put a note right here. Notice there's no plus little r of x. No remainder is used. So if my d of x is a linear function and I have a quadratic function on the top, I could use synthetic division. But if I have an x cubed over an x squared, I will have to do long division. Okay? Next, real quick before I go to there, let me go back to here and explain why we're approaching these spots. So think about infinity again. If the top power is x, let's say to the first, and this is x squared, I have infinity to the first power, infinity squared. Who's bigger? Obviously infinity squared. It doesn't matter if you add another infinity to it. Infinity squared is huge. You're going to have a relatively small number over a huge number. It's approaching 0. If my two powers are the same, now I have, let's say 2x squared over 2x squared. X squared or infinity squared, they're the same value. Multiplying by 2 is the same value. 2 over 2 cancels out to a 1. Or if I had 3 over 1, then I have a horizontal asymptote at 3. If I have 1x squared over 2x squared, then I have a horizontal asymptote at 1/2. And case number 3, if this is the 3 and this is a 2, x infinity to the third power over infinity squared, this is much bigger than this value, so we're heading off to infinity. We are not heading off to a constant value. Number 4, we want to find all our x-intercepts. This is taking the numerator's factor. So now you go to all the factors in the numerator, set those equal to 0, solve for x. These will be your x-intercepts. Remember, these are going to be written as a point, an ordered pair point. Your y-intercept, this is looking at your polynomial form. Let me go back here real quick and show you. It's your constants at the end. You put 0 in for all your x's. They all cancel out, and you're left with c over d. That's my y-intercept. So when we want to graph, what we need to do is you need to graph all your x concepts first. So vertical asymptotes, what we're going to do is we're going to draw the x-axis, and you are going to graph an open circle on the x-axis because we can't touch that number. So we graph it as an open circle. X-intercepts, we'll graph those as closed circles on the x-axis. Notice I haven't done anything with horizontal asymptote or y-intercepts. I don't want anything to do with the y's right now. Once I have these open and closed circles, this is where we're going to go back in time and grab a concept from our leading coefficient, left and right hand behavior. Remember we said that the right hand behavior, no matter what the power is, whether it's even or odd, the right hand behavior is determined by the sign of the leading term. So if my sign is positive, my right hand behavior will be positive. And then every one of these points, your signs will alternate as long as they only occur once. If they occur twice, then your signs will be adjacent. They got to be both plus plus or minus minus on both sides of that circle. Okay? So again, right hand behavior, like I said, was the same for both even and odd powers. That's important. I told you this was going to come back, so I wanted to say it again. And again, that comes from our leading coefficients. If I have a positive on the top and a negative on the bottom, a positive divided by a negative is a negative, your right hand behavior is negative. And then you alternate the signs after all those circles. And the last thing is holes. Holes will occur when there is a binomial factor that is the same in both the top and the bottom of your fraction. They will cancel out the binomials, but what that does is that's going to eliminate a vertical asymptote and an x-intercept. So an example would be, let's say I factored out my two quadratic polynomials top and bottom, and I have an x minus 3 both top and bottom. They are going to cancel out, but I don't throw it completely away. This is my new rational function, but my hole is going to occur when x is equal to 3. So to find the hole, you take this 3, you plug it back into this new fraction. Don't plug it in here because you'll get 0 over 0. Plug it in here. So 2 times 3 is 6 minus 1 is 5. 3 minus 2 is 1. You have a hole in your graph at 3, 5. And then when we get to one of those examples, I'll show you how the vertical asymptote and the x-intercept kind of compromised and canceled out.